Okay, so in this lesson, we're going to look at quadratic. So I just want to practice some factoring of trig expressions with you before we get into the actual questions. So I want to factor sine squared plus 2 sine x. Here's my tip for you. It's just like factoring x squared plus 2x. So even if you want to, you can factor by substitution, but it's the same idea. Let me show you what I mean. If I have x squared plus 2x, I know that factors as x times x plus 2. So sine squared x plus 2 sine x will be the exact same thing. It will be sine of x times sine of x plus 2. Okay, so it's just like factoring normal quadratics. Let's say I have this one here. So I have 3 sine x cos x minus 6 sine x. Let's just, oh, I almost canceled my whole recording here. Okay, I'm having a little bit of difficulty. Bear with me here. I'm trying to get my tip for you. I don't know if I'm going to be able to do it. There we go. Okay, so this is just like factoring 3xy minus 6x. So where x would be sine and y would be cosine. So if I were to factor this, I would take out a GCF of 3x, and I'm left with y minus 2. So I know that 3 sine x cos x minus 6 sine x factors as 3 sine x bracket cosine x minus 2. So if it helps you, you can factor by substitution, or you can just factor using GCF with the trig functions, whichever you're more comfortable with. Okay, now I have a trinomial, so 2 cosecant squared minus 3 cosecant plus 1. Again, this is just like factoring a quadratic, so it's just like factoring 2x squared minus 3x plus 1. So I know that this one here factors 2x, 1, and 1, minus and minus. So I know it factors like that. So then just replace the x with a cosecant x, and I have the factors. Okay, so that's how you factor. So the reason that we have to practice this is because quadratics, we have to factor and then set each factor equal to 0. Okay, so solving quadratic equations, any kind of a quadratic equation, we always set it to 0 and factor fully. Now, because we have trig functions, after we set each factor to 0, we solve it just like we did in part 1 of the video. So find all the solutions within the specified domain. And of course, my most important step, we need to check your answer. Okay, let's go ahead and try this one here. So tan squared plus tan x equals 0. We're looking for all the solutions between 0 and 360. Now, really important to note that tan has asymptotes when cosine equals 0, and it has x-intercepts when sine equals 0. So what we're going to be doing when we look for this question is we have to state some restrictions, okay? So I know that there are some restrictions here when cosine is equal to 0. So cosine is equal to 0. Now we're dealing with degrees at 90 degrees and 270. So I know that can't be one of my solutions, okay? So let's go ahead and solve this. I'm going to solve it by factoring. So GCF of tan. So take out my GCF. Okay, so it factors as tan x times tan x plus 1. And you can always check just by distributing that back in to see that it has the right answer. So now that it's factored, I know tan x equals 0 or tan x plus 1 equals 0. So tan equals to 0 when sine equals to 0. So I know that sine is equal to 0 at 0 degrees, 180 degrees, 360 degrees. But this round bracket tells me it doesn't include 360. So I just have solutions of 0 and 180. Okay, let's solve this next one. So I'll subtract 1 from both sides, and I get tan x equals -1. So tan is -1. So tan is negative using our cast rule. I always like my cast rule for tangent. So tangent is negative in quadrants 2 and quadrant 4. The reference angle is for tan to equal 1, and tan is a ratio of sine over cosine. So you have to look at where sine and cosine have the same value, and that happens at 45 degrees because they're both root 2 over 2. So I know my solution here for 45 degrees. Let's put it into quadrant number 2 so that will be 180 subtract 45, which is 135. And then in quadrant number 4, it will be 360 minus 45, which is 315 degrees. Now, neither one of those are the restrictions, so it looks like I'm good. Let's just put our solutions in numerical order. So it could be 0, 135, 180, or 315. Okay, always go and do your check. Make sure your mode is in degrees. So there's all my solutions, 0, 135, 180, and 315. They all work, so I know that I am good. Okay, this question here. So I want to solve it. So I want to solve it by setting it equal to 0 first. So I will subtract sin x from both sides. So with quadratics, we always set it to 0. Now I'm going to factor out my GCF of sin x, and then set each factor equal to 0. Okay, so I'm looking for solutions between negative pi and positive 2 pi. So let's do positive 2 pi first. What that just means is I'm doing one counterclockwise rotation. So sine is 0 at 0 and pi and 2 pi. But that round bracket says I'm not including 2 pi. So for sine equal to 0, it's just 0 and 2 pi. Now let's look at the negative pi. So this is 0 to 2 pi. Let's look at negative pi. No, other way around. It would be 0 to negative pi. That is this, just right to there. So I can include 0, which I already have, and it includes square bracket negative pi, so I can add on a negative pi. So my solution here for sin x equals 0 would be 0 and positive negative pi. Okay, let's go over here. So I am going to add 1 to both sides and then divide both sides by 2. So sine is equal to a half. So sine is equal to positive numbers in quadrants number 1 and quadrant number 2. Quadrant number 1, quadrant number 2. So you can see, oh, it kind of looks like a little happy face there, doesn't it? There's no solutions in here. So sine x equal to a half has no solutions here. No solutions there. So I only have to focus on the positive solutions for quadrant number 1 and quadrant number 2 here. So I know that sine is a half at 30 degrees or pi over 6. So in quadrant number 1, it's pi over 6. And in quadrant number 2, the numerator is 1 less than the denominator, which is 5 pi over 6. So let's put all of those answers together in numerical order. So I'll go 0, pi over 6, 5 pi over 6, and then I'll state it as plus or minus pi as my solution there. So those would be all of my solutions. So again, I'd want to check that on my calculator, and you can see here's my solutions. So I've got 0, it works, pi over 6, it works, 5 pi over 6, and positive and negative pi, it also works. So it looks like we got all of our solutions. Make sure your mode is in the correct mode for your domain that's specified. Okay, so let's try this one here. So it says solve in degrees, and there's no domain specified. So for these questions here, remember, no domain specified means general solution. So let's solve this quadratic, first of all, by setting it to 0. And I'll add 1 to both sides. And then I'll just solve this by factoring. So I have 2 cos x and cos x, 1 and 1, negative and negative equals 0. Okay, so I'll set each factor equal to 0. So 2 cos x minus 1 equals 0. So 2 cos x, add 1 to both sides, and divide both sides by 2, half. Over here, add 1 to both sides, like that. So solving it in degrees, I want to find all of the solutions from 0 to 360 and then add on multiples of the period. Okay, cosine equal to a half. First of all, cosine, your x-coordinate, is positive in quadrants 1 and 2. Or using your cast rule, you can also see it is positive in quadrants 1 and 2. So my reference angle when cosine is equal to 0. Go into quadrant 1, looking on your unit circle where cosine is equal to 1/2, or using your hand trick, cos is equal to 1/2 at 60 degrees. That's my quadrant 1. And then in quadrant number 4, it will be 360 minus my reference angle. So 360 minus 60 is 300 degrees. Okay, cosine equal to 1. You're looking for your x coordinate where cosine is equal to 1. So since cosine is equal to 1, I know it is a quadrantal angle. So I'm looking where x is positive 1, and that happens at 0. Okay, so I have all my solutions, so I want to put them together in a general solution. So x can equal to 0 plus multiples of the period. X can equal to 60 degrees plus multiples of the period, or x can equal to 300 degrees plus multiples of the period. Now, you don't really need 0 plus. You could write this here as just 360n. I'm fine with either, okay? For each of these questions, n is an integer, meaning I can have a positive and negative rotation, clockwise and counterclockwise. So I can check all of my solutions in my calculator to make sure that I'm correct. Okay, I wanted to do a diploma example with you. This is a written response question. So written response, really important that you guys are showing your work. So algebraically solve the equation secant squared theta plus secant theta equals 2, where, now this is the first time we've seen this. They're specifying the domain has to be between 2 pi and 3 pi, stating the solution as an exact value. So first of all, let's talk about what this means. So all 2 pi means is that I've gone around the circle once, that's 2 pi. So I'm going from 2 pi to 3 pi. So my solution is going to be, right now I'm at 2 pi, so it's going to be from 2 pi over to here, which is 3 pi. So basically my solution is just in quadrants 1 and 2. So quadrant 1 and quadrant 2. Okay, let's look at my question. So it's secant squared theta plus secant theta minus 2 equals 0. So subtract 2. Okay, so let's go ahead and factor this. And I'll factor it with my secants. So secant and secant. Then I'm going to do 2 and 1, and this will be positive, and this will be negative. Okay, so set each factor equal to 0. So secant equals, let me do it. I'll do all my steps, sorry. Secant theta minus 1 equals 0. Add 1 to both sides equals 1. And then here, secant theta plus 2 equals 0. So secant theta equals negative 2, subtracting 2 from both sides. Okay, so instead of working with secant, let's work with its reciprocal trig function. So secant goes with cosine. So if secant is equal to 1, cosine will equal to the reciprocal of 1, which is still just 1. If secant equals negative 2, cosine will equal to the reciprocal of negative 2, which is negative 1 over 2. So remember, negative 2 is like negative 2 over 1, and when I take the reciprocal, it's negative 1/2. So if I solve for cosine with the reciprocal values, it will also be the answer for secant. Okay? So stating the solution as exact value, again, tells me I'm a point on the unit circle. So cosine is equal to 1 at 0. So what I need to look at is, it's not 0 because it starts at 2 pi. Now it's equal to 2 pi, so I'm going to say that it is equal to 2 pi. It can't equal 0 because that's not in the domain restriction. So we have to go around the circle, and it's 2 pi. Let's look at where cosine is equal to negative 1/2. So cosine is your x coordinate, and you want to look where is x negative, but it can only be negative. Sorry, I'm just trying to scroll up here. There we are. Can only be negative in quadrants 1 or 2, because that's where we're dealing with, quadrants 1 or 2. So cosine is negative in quadrant number 2. That's where x is negative. Or you can look at your cast rule and see cosine is negative here. Okay, so I know it's in quadrant number 2. Now I need to look at the reference angle for 1/2. So cosine is 1/2. So go into quadrant 1 where all of your numbers are positive. Look where the x coordinate is 1/2, because cosine is the x coordinate. Or using your hand trick, look for the x value where it's 1/2. So that is going to be 60 degrees, or in radians, pi over 3. So now that I know my reference angle, I can place that into quadrant number 2. And in quadrant number 2, the numerator is 1 less than the denominator, so it's 2 pi over 3. So we have the solution, so it's 2 pi over 3 and 2 pi. So I'll write that like this. This would be my solution. No, it would not be 2 pi over 3. I changed my mind because it's got to be around the circle in that quadrant. I almost made a mistake. It's not a mistake if you catch it yourself though, right? Okay, so 2 pi over 3 does not fit in my domain restrictions. So what I need to do, let me just erase this mistake. Okay, so it is 2 pi over 3, but it doesn't fit the domain restriction. So I have to go all the way around the unit circle again. So I'm going to add on a 2 pi. So if I add on a 2 pi, so I have 2/3 of a pi plus 2 pi. So that's like saying 2 out of 3 pi plus, let's make this out of 3. That would be 6 pi over 3. So 2 pi over 3 plus 6 pi over 3 is 8 pi over 3. Much better. Okay, so making sure it's within that domain. So my answer would be 2 pi, which is the smaller one, and 8 pi over 3. That would be your solution. So what the diploma was trying to get at with this one here is coterminal angles. So it's testing you on coterminal angles, reciprocal trig functions, and exact values on the unit circle. So this is a great question that kind of encompasses all of that. Okay, so then we can check again. So 2 pi, 8 pi over 3, you can see that it works for both. And it fits the domain restriction. So if I would have put 2 pi over 3 in here, it would have worked, but it wouldn't have been the correct solution because it didn't fall within the domain. So that, my little mistake that I made there is actually a good lesson for you guys. Not only are you checking in the calculator, you should also check in the domain restriction. And that's how I caught my mistake before I moved on, is I looked up at my domain restriction and said 2 pi over 3 is definitely not between 2 pi and 3 pi. So that's how I kind of caught it. Okay, this is another question that they had on the diploma. So they have points A, B, and C are on the terminal arms of an angle drawn in standard position. The angles are the solution to a single trig equation. So they're giving you the reference angle. And now they're asking you to state the general solution for this equation. Okay, so for this one here, let's do my first one. I'm going to use a different color pen for each one. So let's state my first solution. So my first solution, and your solutions are always from 0, will be to here. Okay, so the reference angle you can see for both of those angles is pi over 4. Now my first solution is in quadrant number 2. So in quadrant number 2, my numerator is 1 less than my denominator. So my general solution would be 3 pi over 4. Now the question is, what period are we going to add on? So if you look at this, let's look at the cast rule. So this solution has values that are in quadrant 2 and quadrant 3. What do quadrant 2 and quadrant 4 have in common? Well, here I know sine's positive, here I know cosine's positive, so they don't have that in common. What they both have in common is in both of those, tan is negative. Okay, so since tan is negative, my solution is a tan solution. So remember, when we find general solutions, we find all of the solutions between 0 and the period and add on multiples of the period. Well, tan has a period of pi. So my solutions should only be from 0 to pi. So if I highlight it, my solutions should only be in here from 0 to pi. So that angle down there, I don't need to state the solution for that. So this is a really good question because they're testing you to see, do you recognize this is a tan function? Do you know that the period of tan is pi? Because a lot of people might do 3 pi over 4 plus 2 pi n, and then they would say, okay, in quadrant number 4, the numerator is double 1 less, so double 1 less would be 7 pi over 4 plus 2 pi n. Now this is technically correct, but people marking the diploma would not give you full marks for this because you show you didn't recognize that it was a tangent function. So while this answer is good, this answer is better, and the better answer would be 3 pi over 4 plus multiples of pi n. Because if I take 3 pi over 4 and I add pi to it, I would get 7 pi over 4. Okay, so you have to write it in the simplest version using the period. Okay, so this is a great question. Tricking you, not tricking you, testing you to see if you know it's a tangent function. Okay, so that would be my solution. So to summarize my lesson, when you're solving quadratics, set the entire equation to 0 first. So that's different. In linear, we had variable on one side, number on the other. This time, everything's on one side, set it to 0. Okay? Factor the equation, and then once you factor the equation, you have linear factors, and you can state them solve them just like we did before. Okay, so state all your answers within the restricted domain. If no domain is specified, you give a general solution. And of course, always check your answer, most important part of the question. This is probably my favorite trig joke of all times. So couple sitting here at the bank. So, okay, Mr. Walters, just sign at the X. And Mrs. Walters, I'm going to need you to cosine for this tangent. Doesn't get any better than that.